Nice of her. So happy Pi Day. Yes, if you didn't get pie, then make sure you do, because it's a great thing on a beautiful day. I want to let you know just a couple of quick things about logistics. The retake is now available for the quiz. If you wanted to do a retake, you need to make sure that you do corrections on the original quiz. You're going to do that on separate paper. So you write number 1 and then tell me the right answer and tell me why, but you're just not writing it on there. So make sure that you do that if you have not, or if you are intending to take the retake. And then the other thing that I need for you to do is to make sure that you have all your homework done. So I will check that through. That is all up on Canvas. I think that it's all there. I'm just going to pull it up for you to make sure that we're all together on this. So here is the calendar. I'm kind of updating one day at a time for homework here, but the homework up here, the top 3 are the ones that I would be looking for you to take that quiz, okay? Or take that retake. Just since we have this up here so that we can just take a peek at it. So yesterday we did the standing waves lab and constructive and destructive interference. Today we're going to talk a little bit about standing waves just to make sure we've got that really in our brains. And then we'll talk about sound waves, sound production, frequency, and that kind of deal. And then tomorrow we're going to talk about resonance. I was debating. I think I'm going to do the lab when we get back. I think that'll be a better deal. So we'll talk resonance tomorrow, and then Beats lab when we get back. And then we're pretty much done with sound. Like that is it. There's like one other little topic, but I'm going to wait until we get to light because I like to put them together. So we'll do that. And we'll do another quiz then the middle of the next week that I see you. Does that make sense over this stuff? The way that this kind of unit fits together, we're just kind of big picture for you in case you're curious. We're going to do this basic waves and sound, then we'll do light, and then we'll take a quiz over that, and then we'll do a big test over all of those pieces together. Okay? Questions that you have right now about the logistics of that stuff? Sweet. Okay. So going back to our list of things to do, we had some homework yesterday, 36, 42, and 46. I don't know if there are any questions that you all have over those right now. I'm going to open that up if there are. Okay. If you run into questions, you know where to find me, and we can talk about them anytime. So we're going to jump in and go ahead and do some stuff with standing waves today. So I think that this is where we ended yesterday. Does that look right to you? So pull your notes out. And if you haven't yet drawn that standing wave with 4 nodes and 3 antinodes, go ahead and do that. If you have, then check with your neighbor and see if they agree to make sure that we're all in agreement about what that will look like.
Do we need a whiteboard?
You may need a whiteboard today. Yeah. Do you want to get whiteboards? We are going to do a couple of ranking tests today. Yes. I know, just to make you happy, my friend. They are good. It's a good way to use your brain, isn't it? Yeah.
Does everyone want one?
Yeah, every table. You have every table one.
Okay.
We like to do collaboration. Collaboration is good. So again, double check. Make sure that you've got a standing wave with 4 nodes and 3 antinodes. I would say that's true. So if we're not sure, let's define these words. Just maybe that'll help us a little bit. What is a node? We've talked about this a couple of times, but let's do it one more time. What is a node?
No movement.
It's a place of no movement, right? And antinodes, using our awesome English skills, if it's not a node, it's an antinode. And what would an antinode be then? A lot of movement. Yes, yes. So maximum displacement. So hopefully that helps. Talk to your table mates. Get it figured out. Okay, so let me see. Is this better? That's better. The top one is better. Yes, 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 yes. Okay, so let's take a look. So we're going to see if this actually works here. All right, so 4 nodes. Those nodes are going to be those dots, right? And 3 antinodes. Oh, it's on freeze. You can't see my picture. Why isn't what? No, I'm just trying to like get you. Oh, that's really ugly. Don't look at this bottom one. Holy cow. Yuck. There, that's a little bit better. Okay, so this is the way that one would draw a standing wave. If you have just one round of it, so you have, if you have just that part, then what you're drawing is it's not wrong, but it doesn't really represent a standing wave so much, okay? So the way that this works is that at any given moment, if you took a really fast picture of this thing that you've got as a standing wave, and it was a really fast, really fast capture, so it didn't get the blurriness, then you would just see it as that yellow line, right? Or some moment later, it might be like this. Or some moment later, it might be like this, right? Because it varies over time. Some moment later, it's going to be like this. But if you look at it, if you look at that standing wave when we were doing the lab, you saw it looked like the pink and the yellow put together, right? Okay? Because that's what happens as we kind of see, because our eyes don't resolve things fast enough. So our eyes see it both as the yellow and the pink. So the yellow and the pink are both part of what I'm going to call the standing wave. Okay? So the game with standing waves, we've mentioned this before, but I just want to make it very formal and very clear to you all that standing waves are a direct result of both constructive and destructive interference. Okay? Where in this picture would we see destructive interference? At the nodes. Why do you say at the nodes?
Because it's at 0.
Mm-hmm. It's at 0. That means the amplitudes are subtracting, or they're making it smaller, right? When you send that wave down, you had that slinky out and you sent that wave down, you were causing a displacement of that slinky, and that displacement went all the way down from your hand to your partner's hand, right? It bounced off your partner's hand and bounced back, and the wave that you send down and the wave that was bouncing back towards you, they interact, just like we did yesterday, just like this stuff was, okay? But the waves that we see are going like this. They have the same amplitude, and so when they get to the same place, destructive interference amplitude of 0. Okay? Now, this one's a little bit different, so I'm actually going to make a little arrow here to say the no movement, that's right there, and that is, as we just said, destructive interference. The other places aren't destructive, though. Okay? Because you've got one wave and you've got another wave, and the waves are interacting with each other and they're getting bigger. What's that called? That's constructive interference, right? Okay. So antinodes, maximum displacement, and we've got constructive interference going on there. Okay. Based on your experience with the lab a couple days ago, we're going to put a couple of points down, I guess. First one, as the number of, well, let me back up my brain for a second. The number of nodes depends on what? How were you able to achieve different numbers of nodes when you did this? What is that? What is that called, though?
Energy.
What's that? So the amount of energy and the frequency, those are two options, right? The amount of energy, how do you quantify the amount of energy in a wave? I mean, you're not wrong. So I'm gonna take it where, so Isaac just said force times distance, right? Why did he do that? Because he's being a little bit snarky, perhaps. But I like to embrace the snark sometimes, and today's one of those days. So we're gonna walk it back here. Work is change in energy, right? Work is force times distance. Were you doing work when you made your standing waves? Yeah. Y'all were like huffing and puffing and getting mad because it was really hard, right? This is hard what? It's hard work. Were you applying a force over a distance?
Yeah.
For sure you were. Which way were you applying a force? You were pushing it back and forth, right? Yeah. And as you did that, you were adding energy to the system. Are you with me there? And the more force you add, what would that change about the wave? You made more force. Right? Force over distance, they're in the same direction. I'm applying a force this way, over a distance this way. If I want to increase the amount of energy, more force, more distance, more energy, what is that going to change about the wave? Is that going to change the frequency?
Yeah. It's going to be, yes.
What is the frequency? So I'm gonna draw my little slinky over here. That's supposed to be all even. You applied a force in this direction over some distance in this direction, right? And in doing so, you did some work. You added some energy to the system. What is frequency?
Vibrations.
Frequency is the number of vibrations or number of cycles per second, right? Or per time? I need your brains on for just a moment, if not for the rest of the period, but for just a moment so that we can look at this and answer it thoughtfully. Does increasing the force or increasing the distance change the number of cycles that you're going to move every second?
Well, you have to choose.
Ben, go grab one of those slinkies. Everybody come up here. Sam's going to grab one end. Leanne's going to grab the other end. Come on up. Quick, quick, quick. Everybody come on up. No, you guys come up too. Everybody's coming up. Come on.
Wait.
We're going to look. Everybody sit on the floor.
Everybody.
We're doing standing waves live again. We got to see it. So I want to make sure it makes sense to you. I want you to use physics. Sometimes, I don't know, somebody in one of those surveys said, why do we have to apply stuff? I don't care. We're doing physics, right? Physics is physics. All right. So Sam, you're going to make a standing wave. Go ahead and do that.
Is that it?
I don't know. Is that like a standing wave?
Yeah.
Yes.
That's pretty good. Okay.
1, 2, 3 internodes.
Love it. Okay, nice job. Were you applying a force over a distance to do that?
Yeah.
Sure, she was, right? Her force was going this way, and then this way, and then this way, and then this way over some distance. Yeah? In doing that, you were doing work. You were changing the chemical energy from the whatever you had for lunch. What did you have for lunch today?
Bagel.
Bagel. From the bagel she ate into kinetic energy in the slinky. Yeah? Okay. So now, I want you... I'm trying to figure out how to word this well. Can you do another standing wave with 3 internodes?
Is the one I just did?
Yeah, same one you did. Beautiful. Now I want you to move your hand back and forth less distance. Can you do that and still maintain a 3 antinode standing wave?
No, not really.
Try harder. The answer is yes.
Oh.
Nope,
Sure.
nope. You're changing your frequency now. You can do it. Okay, can you make one with bigger amplitude? 3 antinodes, 3 antinodes, 3 antinodes. That's 2 antinodes.
I can't do it.
Yes, you
I
can.
can't do it.
Yes, you can.
I can't do it.
Slinky.
All right.
Question.
Okay, here we go.
Oh, that was only 2.
You were excited about 3. I'll do 2. So I'm gonna do 2. You with me here? Am I applying a force over a distance? Yes or no?
Yes.
Yeah.
Yes.
Correct.
Am I applying a force over a distance?
Yes.
Yeah. What is changing?
Distance.
The distance that I'm applying the force over, right? And what does that change about the wave?
It's amplitude.
Its amplitude. Has it changed its frequency? Am I changing the frequency with which I'm moving my hand?
No.
No. All I'm doing is changing the distance that I'm sending it, right? You with me there? Okay, take this back. I want you to get a standing move with 2 antinodes, just like I had it. So I know you can do it. That's beautiful. Okay. So now, when you change the frequency, what does that do to the number of antinodes? That's not frequency. What is frequency, friends?
Cycles. The number of cycles.
Yep, so what does that mean? Because Sam's
More
like,
antinodes.
Sam is number one going, why in the world did you pick me for this? She's saying, I don't understand what you're asking, right? Yeah. And saying, don't judge me, friends, help me, right? What does it mean? So I'm asking you all, if you were in Sam's spot and I asked you to increase the frequency, what does that mean to you?
More antinodes.
But how does she do that? How do you increase the frequency? You move faster. Yep. Does the distance matter? In terms of whether or not you're going to get more antinodes or not?
You can put more force.
Sure. You got this. Come on. There you go. There. That's beautiful. That's fantastic.
Oh, trust.
That's fantastic. Can you make more?
No.
Yes, you can. Don't move your hand quite as far. There. That's beautiful. See what I'm saying?
Yeah.
So she was moving her hand the same distance on all of those last few. Did you catch that? Same force, same distance. That means it's the same amplitude. That means it's the same amount of energy. But the number of nodes, what did it depend on? You just saw it.
Frequency.
It only depends on its frequency. Are we okay? We doing all right?
Yeah.
Do you want to make Leanne do it?
Because the more
Yeah, let's make
antinodes
Leanne do
you
it.
have, the more nodes
Yeah,
you
Leanne.
have.
Do it, Leanne. How many can you get? What? Wait, you stopped. I didn't even get a chance to count. 1, 2, 3, 4, 5. Nice. Is that 5 or 6? I don't know. That was a lot. Awesome. Nice job, friends. All right. Bring that back and set it right up here. Okay, that was a long conversation to get something, but I'm hoping it makes sense to you. Ben, did you have a question? Okay. I wanted to make sure I wasn't like missing like a hand in the air thing. Okay.
Thank you, though.
My pleasure. Sometimes I do miss it. Yeah. And then I feel bad. Like, are you ready? Not quite? Okay. I can wait. You got an answer? Do you actually, because you're not a loaded question, do you feel like with more time you will come up with answers, or you're just not sure what to do? Either answer is fine. I'm just engaged. Yes to the optional question?
Yeah.
Do you have an answer? You're almost there? Like another 1 minute? All right, I'm going to start because I don't know why, because I'm mean or something.
We have another one.
Another ranking task?
It'd be tricky like this one.
Um,
I guess so.
It's not. That's the thing, and that's why I was saying because Megan's upset with me because she thinks it was whatever, but it really was because you guys know more than you needed to for this. Sometimes when you have too much knowledge, it gets dangerous, doesn't it? That's what happened. You know too much now. So in A, you have 2.5 wavelengths, and the length is 25. So how long is each wavelength? Can you figure it out?
So we were
25 divided by 2.5, right? You have 3.5 wavelengths and 28 centimeters. How long is each wavelength? Half of me as a teacher is saying, wow, I totally screwed that up. Like, wow, I should totally have done this in a different order. Like, maybe I should do it differently next period. And half of me is saying, this is great. Because this is what happens when you take a test, right? Or a quiz. You have a lot of knowledge. And you have to figure out what knowledge to apply when. And this was tricky. I agree. Like, it was not obvious.
Make them struggle. I'm joking.
I'll tell them. I'll be like, Megan told me, or not Megan. Sam told me to wait. Give this to you now.
Make them.
No, I'm just going to say that he told me to give it to you.
The number of
No, I told them to.
By yourself at the board?
Lily, how do you do this?
So what was that quote?
No, for real, make them struggle. Yeah,
It's DACPA? It's DACPA. Yeah.
Well,
These standing waves are not identical, so the answer is not going to be just the inverse. When I first saw this problem, I found the other one first, and I found this one. I'm like, oh, well, it's just going to be the flip, right? You got wavelength, got frequency, blah, blah, blah.
Sorry.
But it's not, because it's a different picture.
Oops. You know, me and Megan have gotten started from being in this class, away from our friends.
Yeah.
Yeah. Our brains are increased because they just talk all the time.
Well, I'm glad you're here.
I'm glad you're here too.
The lady who made your nails red?
The same size.
the loss is the same, right?
Yeah. She makes
You divide by the wavelengths. Make it a wavelength. Yes.
Oh my gosh. Are you ready? Oh, okay, sorry. So you know that the tensions are all the same, which means that the velocities are the same, right? Can you find the wavelength?
Yes.
And if you find the wavelengths, then can you rank the frequencies?
Nope.
The number of wavelengths.
It's not cannot be determined.
I cannot. Wait, is it?
That's
Make
not
Lily
the
do
wavelength.
this.
Make Lily do this one too.
Don't show everybody.
Divide that.
She's got it. She's shy.
I'm seeing how many wavelengths we had.
No. Actually, find the number.
I told you that. Jeez, God. Seriously.
Come on, friends.
Are we ever here?
I think we have the same, we have it right.
Divided by.
Yes. Oh, those.
Well, we. You have a theory. I love theories. What is your theory? Okay.
No, this isn't ours.
They all have the same velocity. It's actually the opposite way.
What'd you get for 20?
So if they were all the same length, kind of like with the last one, if they were all the same length, then you would, then that would work.
I think it's.
But because they're not the same, so you have to do the same kind of process that we did in the last one, where you figure out how many wavelengths there are,
You get that.
and then figure out from that what the wavelength is. Does that make sense?
This is the wavelength.
Are we ready?
So if you divide, if I'm just saying the loss is 4 meters, so if you do 4 divided by 10, that's 2/5. 10 2/5.
Ben, did you guys get it?
81.5.
Yeah, they had the same thing as us.
I was practicing for what I'm on vacation.
Oh,
I
yeah.
had the line, like,
I can honestly say I have no idea what you're talking
you
about.
have to look it up. You guys know what I'm talking about?
So then-
When they're like, I'm saying to go, like, you're watching this, and you get a one, they're like, dude, do you?
That's why I had it.
I'm just
This is
practicing.
the ring question.
But you didn't watch
Yeah.
Disney?
Yeah.
Well, now New Disney just has a little.
In centimeters, yes.
All right. Let's do it, my friends. So answer bad. Is that what you're saying? BADC. Oh, that's always, it always happens that way, doesn't it?
Jeez.
DC? Yeah?
Yeah.
Yeah. It should be DC. We can go through it tomorrow if you want. So we will do some stuff tomorrow. It'll be great. And then it'll be spring break. Yeah. If you didn't get pie on your way in and you would like one, knock yourself out, friends.
Oh, Jordan.